Math 3 Honors, Unit 8, Worksheet 7. We're going to go through 3 examples to help you out with Worksheet 7. So you can see I have an equation here, and whenever we are solving for theta, which is what we're asked for, we're going to solve for all values of theta such that theta is in between 0 and 2 pi. Can be equal to 0, but we don't want it equal to 2 pi. So we're going to use 0 there instead. At that full circle mark, we're going to start at 0 instead. All right, so with this equation, there's going to be a lot of factoring, whether it's greatest common factor, factor by grouping, stuff like that. Difference of squares, whatever you have. We've done a little bit with this in previous sections, but we're just going to look at some more complicated problems. So on this one, I can see that I have 2 terms. So 2 terms separated by subtraction. And my 2 separate terms have a factor in common of tangent of, that should be 3 theta, tangent 3 theta. So I'm going to go ahead and factor out that tangent of 3 theta to the front. And that leaves me with secant of 2 theta over 3 minus 2. All right, now because I have 2 factors that are being multiplied together, I can use my zero product property. In other words, I can set both of them equal to 0. So I have tangent of 3 theta equals 0, and I have secant of 2 theta over 3 minus 2 equals 0. All right, so let's talk about this first one. So I have tangent equal to 0. That means I need to get 0 over 1. And I know that tangent is sine over cosine, so that means my sine needs to be 0. And my cosine could be positive 1 or it could be negative 1, because 0 over positive 1 or 0 over negative 1 gives me 0. But I don't want my denominator to be 0, which means I don't want cosine to be 0, because that would be undefined, not equal to 0. So over here at 0, 0 radians, all right, 0 radians up above, then my point is 1, 0. And at pi radians, my point is negative 1, 0. So those both give me a tangent value equal to 0. But see this 3 theta right here? We talked about this a little bit in class, but we're going to talk about it more right now. This 3 theta means basically we're going to go around the circle 3 times, the unit circle 3 times, in order to find all of our values. And I'll show you a little bit more about that in a minute, but let's go ahead and find our other values if we were to keep going around the circle. So start at 0, and then we go halfway around the circle to pi. If I come around again, I would be at 2 pi. Halfway around again would be 3 pi. So that's twice around. And then we're going to go again, which would be 4 pi and 5 pi. So this 3 theta right here is actually equal to each of those values, because tangent of 3 theta would be 0 pi, or tangent of 3 theta get me 0. 3 theta would be 0 pi, 2 pi, 3 pi, 4 pi, or 5 pi. So I'm just going to set a list. So we have 3 theta can be equal to any of these values. Oh, I skipped 2 pi. 2 pi. So 0 pi, 2 pi, 3 pi, 4 pi, 5 pi. So those are our 3 turns around the circle. All right, and then we're going to go ahead and solve for theta now. So if I solve for theta, that means I'm dividing by 3 to each of these values. So if I divide by 3, 0 divided by 3 is still 0. Pi divided by 3 is pi over 3. Two pi divided by 3 is 2 pi over 3. 3 pi divided by 3 is pi, because those 3's are going to reduce. 4 pi divided by 3, 4 pi over 3, and 5 pi divided by 3. All right, so we get those values there. Okay, over on this right-hand side, we have secant of 2 theta minus 2 equals 0. So let's go ahead and solve that. We're going to add the 2 to the other side. Okay, and now this is secant of 2 theta over 3, which means I can't multiply that 3 to the other side. That's not being multiplied by secant, it's part of my angle. So 2 theta over 3 is the angle that I'm looking at, where I'm not sure what theta is yet. So what I need to do here is to find something that's more familiar to me. So right now we have secant, and on our unit circle, we're most used to dealing with sine, cosine, and maybe even tangent. So what I'm going to do is find the equivalent reciprocal. And actually not, I'm just going to take the reciprocal of secant. And the reciprocal of secant will be 1 over secant, which actually equals, hopefully you said, cosine. But if I take the reciprocal of the left-hand side of my equation, I also take the reciprocal of the right-hand side of my equation. What's the reciprocal of 2? Hopefully you said 1/2. So that looks more familiar to us. We know when we find cosine of an angle equals 1/2, there are places on our unit circle that we're used to of having 1/2. So we're going to find that as well. Let's see. So when my cosine value, if I'm going over 1/2, I'm not going over root 3 over 2, so that's a shorter value to go over, a higher value to go up. So you should recognize that this is a 60-degree angle, but we're solving in radians, so you should recognize that this is pi over 3. All right, so then we also want to find any other values that would give us positive 1/2 for our x value. Now, if we went to the left, that would be negative 1/2, so I'm going to stay on the right-hand side. Positive 1/2, again, is going to be over 1/2 and down root 3 over 2. So pi over 3 in the opposite direction, which one full circle would be 6 pi over 3, because that reduces to 2 pi, right? So if I do 6 pi over 3 minus pi over 3, I get 5 pi over 3. All right, so those are some of my values that will give me cosine of theta equals 1/2. So let's go ahead and solve for that one. So we have cosine of 2 theta over 3 equals 1/2, which means 2 theta over 3 is either pi over 3 or 5 pi over 3. All right, so this would give me 2 times theta equals pi. because if I multiply both sides by 3, the 3's would reduce, and this would give me 2 times theta equals 5 pi. Which means if I divide by 2, I would get pi over 2 and 5 pi over 2. Now let's talk about 5 pi over 2. 5 pi over 2 is more than 2 pi. Because, let's see, 4 pi over 2 would be 2 pi. And we can't have values that are greater than 2 pi. So if we know how many times around the circle that we're going, then we should be able to determine when we can stop finding values. So going back to this tangent of 3 theta, remember we said that means you go around the circle 3 times. Okay, and the reason for that is because if I take this restriction that I have in my question and I multiply it by 3, I would get 0 is less than or equal to 3 theta, which is less than, well, I'm multiplying every single one of these by 3. 0 times 3 is 0. Theta times 3 is 3 theta, which is what we want. 2 pi times 3 is 6 pi. You'll notice that the values that I got for my 3 theta when I was solving before, I didn't have any values that were more than 6 pi, which is right here. You'll notice I went 0 pi, 2 pi, 3 pi, 4 pi, 5 pi. If I were to keep going, I would get to 6 pi, but 6 pi cannot be one of my answers because I don't have an equal to under this less than sign. Same thing for over here. This means I go around the circle 2/3 of a time. So half is here, 2/3 is going to be over here. So I wouldn't actually get to 5 pi over 3. And that's why that doesn't help me find one of my answers, because that's outside of my restriction. So I have all of these answers over here, and then one more, pi over 2. As my solutions. All right. So if you want to pause the screen, you can go ahead and pause it and make sure you get all of those written down. And then we're going to move on to the next one. All right. So new problem. We have 3 terms on this one. So what do we normally want to do when we have 3 terms? Hopefully you noticed the sine squared and then the sine to the first power and then a constant, which means we're going to have to factor these values. So we're going to go ahead and substitute for sine, because sometimes this can get a little chaotic if we're not substituting a variable in, so that we can just see what it would look like to factor all this. So I'm going to go ahead and use x for sine of theta divided by 2. So sine of theta over 2 is going to be my x value. So that would give me 4x squared minus 8x plus 3 equals 0. And I can go ahead and factor that. That's going to give me 12x squared. That's going to give me negative 8x. So what numbers multiply to give you 12x squared but add to give you negative 8x? They should both be negative if you want to multiply to a positive and add to a negative. So negative 6x and negative 2x are the correct values there. So I'm going to do 4x squared, replace that negative 8x with the 2 x terms that I just found, negative 6x and negative 2x, and then factor by grouping. All right. So that gives me 2x times 2x minus 3. My greatest common factor on the right-hand side is -1, which gives me 2x minus 3. And now my greatest common factor is 2x minus 3, so that leaves me with 2x minus 1. All right, now this 2x minus 3 and 2x minus 1, I'm going to go ahead and solve for each of those, and then we will plug sign back in after we solve for those. So, zero product property means I can set each of these equal to 0 if they're being multiplied together to give you 0. Okay, so I add 3, divide by 2. Same thing on this side, except for I'm going to add 1 and then divide by 2. And now let's go ahead and substitute sign back in. So for these two values here, I have sine of theta divided by 2 equals 3/2, and sine of theta divided by 2, or theta over 2, equals 1/2. So let's take a look what that's going to look like on the unit circle. So let's talk about sine of theta over 2 equals 3/2. First of all, we're talking about a sine value, right? So sine is, I have a right triangle. That's what we use trigonometry for, is right triangles, right? On the unit circle, we know the hypotenuse is the same as the radius, which is 1, and that sine is my opposite side, so that would be 3/2. Or if you're doing a regular triangle even, and you're doing, so this would be my angle theta over 2. Even if you're doing a triangle that's not on the unit circle, if I did sine is opposite over hypotenuse, that would be 3/2. Now, is this possible? For my opposite side to be 3 and my hypotenuse to be 2? No, because your hypotenuse always has to be the longest leg. Same thing over here, 3/2 is more than 1/2. Your hypotenuse has to be the longest leg. We know on the unit circle that none of our sine or cosine values are longer than 1 whole. And 1 whole is even a special case because that would be on our axes. But anything in between there is going to be some sort of value that's less than 1. So it could be, the absolute value is going to be less than 1. So it can be more than -1 but less than 1. So this is not going to give us any values for theta. All right, but, because that's impossible. But this right-hand side should be one that we're very familiar with. Sine is our y value, right? So I'm going up by 1/2, which means I'm going up a shorter amount than I'm going across. So my triangle should look like this. And going up 1/2 over 3/2 means that this angle is 30 degrees. In other words, 30 degrees would be at pi/6. Now let's talk about something else. This theta over 2 would be only looking at values halfway around the circle. You don't have to worry about that too much when it's a smaller value than theta, but it's good to reference. If it's a smaller value than theta, then we're going to be able to know whether our values are on this unit circle or not, just based off of what we know about the unit circle. So sine is positive 1/2, which means the y value is positive. So that would be quadrant 1 and quadrant 2. That's where our y values are positive. If this is pi/6, that makes this 0 and 12 pi/6, because that reduces to 2 pi. That would make this 6 pi/6 over here. And if I'm writing my reference angles as pi/6, that would make this one 5 pi/6. I'm going to go back 1. All right. And we know that we're not looking at the other half of the circle for 2 reasons. We have pi/2, and also we don't have a negative value. So we only want to look at the top half of the circle, not the bottom half of the circle, if we have a positive sign value. All right, and that's it. So your two, oh well, we want to list out the correct answers. So those values are not our answers. Don't forget about that. Those are the values that we could take the sign of to get 1/2, which means we haven't solved for theta yet. Theta over 2 equals pi over 6 and 5 pi over 6. So you actually have to solve for theta. What are we going to do to solve for theta? You should have said multiply both sides by 2. So if I multiply this by 2, I get 2 pi over 6, which reduces to pi over 3. If I multiply this one by 2, I get 10 pi over 6, which reduces to 5 pi over 3. In other words, you can divide a 6 out of each of those denominators. So those are our only two solutions for theta that are between 0 and 2 pi. All right, if you want to pause right there, you catch up on that information. And we're going to go on to the next one. All right, last one. Once we do this one, you should have enough problems that have the difficulty of what your worksheet is, but if you have any questions, you can email me and I'll make another video. So, let's see, we have 5 cotangent squared of 3 theta minus 15. Right away I noticed that I have a 5 and a 15, so I'm going to factor out that 5. I also noticed that I have cotangent squared, but I have no cotangent term. So I'm not going to be able to factor by grouping, and I'm not going to be able to factor by difference of squares either, because 3 is not a perfect square. But let's see where we go from there. So let's go ahead and divide each side by 5 so I can get rid of that extra 5 that we don't need. Cotangent square root of 3 theta minus 3 equals 0. And I'm just going to keep solving until I get cotangent of 3 theta by itself. So we're going to add 3. Okay, now cotangent is currently squared. So how do I get rid of a squared term? Hopefully you said square root, but don't forget when you take the square root you need plus or minus. So we have cotangent of 3 theta equals plus or minus the square root of 3. Now again, cotangent is not something we're as familiar with looking on the unit circle as tangent is. So I'm going to take the reciprocal of cotangent and I get tangent, which means I take the reciprocal of the right hand side as well and I get 1 over square root 3. Don't forget that plus or minus, because that is an important part of looking for all of our solutions. Now you can leave it like that. You can look at your sine value over your cosine value that way. Or if you need to, you can rationalize it. Whatever's better for you, what makes more sense for you to find your tangent values that you're used to looking for. And let's go ahead and find those answers. So where is tangent equal to root 3 over 3? Where is tangent equal to root 3 over 3? Hopefully you know that it's sine over cosine, so it would be 1/2 over root 3 over 2. And you multiply by the reciprocal, you're going to get 1 over root 3 just like we got here, and then you can rationalize that. So we want the 1/2 to be the y value or the sine value, and the root 3 over 2 to be the cosine value. So that would be at pi over 6. Now I have a 3 theta, so that means I'm going to go around the circle 3 complete times. So I also have a plus or minus, which means tangent is positive, then negative, then positive, then negative, right? So positive, negative, positive, negative. but it doesn't matter because my tangent could be positive or it can be negative. So all of your reference angles that are pi over 6, you're going to draw those in. So that'd be pi over 6, 5 pi over 6. What's pi over 6 more than pi? Hopefully you said 7 pi over 6. What's pi over 6 less than 2 pi? Well, let's write that as 12 pi over 6. So pi over 6 less than that would be 11 pi over 6. That is once around the circle. Then we're going to go around the circle again. So adding pi over 6 to 12 pi over 6, we get 13 pi over 6. All right. Now you can do your increments along your x-axis as well so that you can remember your reference angles here. If this is 0, 6 pi over 6, 12 pi over 6, we're just going to increase by 6 every half turn. So that would be 18 pi over 6. And then this full turn again would be 24 pi over 6. So let's find all of our reference angles in that second turn. So pi over 6 away from that would be 17 pi over 6. Pi over 6 forward would be 19 pi over 6. And then pi over 6 down from 24 would be 23 pi over 6. All right, one more turn. So we have 0, 6, 12, 18, 24, hopefully you said 30. So that would give me 24 plus 1 would be 25 over, 25 pi over 6. This one would be 29 pi over 6 and 31 pi over 6. Both of those. And our last one over here would be 35 pi over 6. If you want to reference the third full turn, you can. That would be 36 pi over 6. Okay, so we have a lot of answers here. And and these aren't even the answers yet. So we have all of these values that can be equal to what we're taking the tangent of, which is, so this is what our angle is equal to. Our angle, 3 theta, is equal to pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. You should have 4 from each turn. All right. Now, we have to solve for theta. So, solving for theta, we're going to divide everything by 3. When I divide by 3, that's the same as multiplying by 1/3. So if I multiply each of these by 1/3, it's just going to change my denominator because my numerator is going to stay the same when you multiply by 1, and the denominator should be multiplied by 3. So 6 times 3 is 18. So you get pi over 18, 5 pi over 18, and then keep going. I can't even, my hand has a mind of its own. So many answers. There you go. Those are all the possible answers for that one. So it shouldn't get harder than that. Let me know if you have any questions.